Namaste. In today's session, in the shortcut series, video series of Polymath, this is the 5th video in which I am going to discuss the partial fractions, how they can be split. A fraction which can be split into two or more than two fractions is nothing but the partial fractions. In the name itself, you can see that. And in partial fractions, there are three types mainly. Number one, the denominator is containing non-repeated linear factors. Number two, the denominator is containing repeated linear factors. Number three, it is an improper fraction. It is an improper fraction. These are the three types of partial fractions. And here, I'm not going to teach you the theory part of it, but I'm going to teach you only the short forms of it. Short forms of it. So how to find out? By avoiding the method. Whatever the method is there, we are going to avoid that method. We are going to avoid that method but with the use of this. So in the partial fractions are mainly used in integration and in binomial theorem also. In binomial theorem, to create the power series, the partial fractions are used. So for this partial fractions, what is the short form? I named it is everywhere but not there. Just see that. Everywhere but not there. Everywhere is the corona principle, COVID-19 principle. You live everywhere in your house, but don't go out of the house, that is not on the road. Not there on the road. Everywhere in the house, not there on the road. So here also we are going to follow the same principle, that is everywhere but not there. But before that, you must know the basics of the partial fractions, that is the number of fractions that are to be written or the number of fractions that are to be split are equal to or less than or equal to the number of factors in the denominator. The number of factors in the denominator, that's what you have to understand. Whenever there is a linear factor, first degree in the denominator, you will have the constant in the numerator. Whenever you have a second degree factor, second degree expression in the denominator, then you will have a linear factor of first degree. When you have third degree factor in the denominator, you will have second degree factor. You will have a second degree term in the numerator. That is what the principle, basic principle you must be knowing. So let us see what is this everywhere but not there. So if you see the first problem, I have chosen some problems just to make you understand this principle. That is, let me start with the basic problem. That is 2x plus 3 divided by x plus 1 into x minus 3. Very simple. Very simple. See the denominator. In the denominator, there are two factors, x plus 1 and x minus 3. X plus 1 and x minus 3. So, correspondingly, you write correspondingly two fractions. One with x plus 3, other with one with x plus 1, the given factor, and the other one with x minus 3. So now, to get the numerator of the first fraction, put x plus 1 equal to 0. Put x plus 1 equal to 0. Everywhere, that is in the numerator and in the denominator, but not there. Everywhere but not there. Put x plus 1 equal to 0 everywhere but not there. Put x plus 1 equal to 0 means x equal to minus 1. Everywhere but not there. I am writing that. Everywhere 2 into minus 1 plus 3 divided by, but not there. Don't write it at x plus 1. So minus 1 plus 3. This is the numerator of x plus 1. This is the numerator of x plus 1. Similarly, to get the numerator of x minus 3, put x minus 3 equal to 0 everywhere but not there. Put x minus 3 is equal to 0 everywhere but not there. Everywhere, that is in the numerator, 2 into 3 plus 3 divided by 3 plus 1 Just say this now. You have a plus here. Just see this now. 1 by 2. So 1 upon 2 into x plus 1, and it is 9 by 4 into x minus. That's it, please. Within one step we can do that, but we avoided the method, which is everywhere. Put x plus 1 equal to 0 everywhere, but not there. If you put it there, that will become, denominator will become 0. That is why you should not put it there. Similarly, x minus 3 equal to 0 everywhere, but not there. Where? X minus 3. At x minus 3 should not put it. Let us go to the next problem. And I changed the problem there. It is x plus 4 into x square divided by x square minus 4 into x plus 1. What are the denominator factors here? X plus 2, x minus 2, x plus 1. So correspondingly, let me write x plus 2, x minus 2, and one more, x plus 1. What is to be done? What is to be done? Put x plus 2 equal to 0 everywhere, but not. Everywhere, but not there. But you have to write that x square minus 4 as x plus 2 into x minus 2. Let me show you that also. Before writing this, let me split the factors. X plus 4 divided by x plus 2 into x minus 2 into x plus 1 is equal to x plus 2, x minus 2, x plus 1. What is that I said? The number of fractions is equal to the number of factors in the denominator. The number of fractions is equal to number of factors in the denominator. Put x plus 2 equal to 0 everywhere, but not there. Put x plus 2 equal to 0 everywhere, but not there. X equal to minus 2. So minus 2. And mind calculation now. Let me write, because it is the beginning of the session, beginning of the second problem, that is second problem in the beginning. That is why. Let me write that. Minus 2 plus 4 divided by minus 2 minus 2. This one. Minus 2 plus 1. Done. So what should it be? Let me write that. 2 by minus 4. Minus 4 into minus 1. 4. 4 by 2 by 4. 2 by 4 is 1 by 2. So it is 1 by 2 into x plus 2. It is done. Now coming to, put x equal to 2 everywhere but not there. Put x equal to 2 everywhere but not there. X equal to 2. 6 by 4 into 3. 6 by 4 into 3. 6 by 12. Mind calculation, please. In the short forms, it is very much essential. You have to develop your mind calculation. Mind calculation is very important. Similarly, x plus 1 equal to 0. Put x equal to minus 1. Put x equal to minus 1 everywhere but not there. Put x equal to minus 1. It is 3. 3 by 1 by into minus 1 minus 3. Minus 1 minus 2 minus 3. 1 into minus 3 minus 3. And it is 3 by minus 3. It is minus 1. You got it? Similarly, put x equal to minus 1. Put x equal to minus 1 everywhere but not there. We did it. We got minus 1. Now the final answer is 1 by 2 into x minus 2. 1 by 2 into x minus 2 minus 1 by x plus 1. That's it, please. Second problem done. What is that we used? Everywhere but not there. Then, very important point to be remembered. Very important point to be remembered. Is this everywhere but not there is useful in every case? No. No, not at all. It is useful only for the non-repeated linear factors. It is useful only for the non-repeated linear factors. Power 1, power 1, power 1, non-repeated. Linear factor x power 1, x power 1, x power 1. For these only it is useful. But we can do some adjustments for this, using this to write the answer directly. Let us go to the next one. 2x square plus 2x plus 1 by x cube plus x square. What is that? Can be taken common in the denominator. X can be taken common. Let me write the entire fraction so that you will also be comfortable. 2x square plus 2x plus 1 divided by x square into x plus 1. Just see that. I have taken x square common. How many factors are there in the denominator? In the denominator, 2 plus 1, 3. You have to take like that. X power is 2 and x plus 1 power is 1. 2 plus 1, 3 factors. So correspondingly, you have to write x square, x plus 1. Okay? Undoubtedly, you can make use of everywhere but not there for this one. Undoubtedly, you can make use of everywhere but not there for this one. X equal to minus 1. Put x equal to minus 1. Everywhere. Put x equal to minus 1 everywhere but not there. Put x equal to minus 1 here. 2 plus 1, 3. 3 minus 2, 1. 1 divided by minus 1 whole square. This is minus 1 whole square, 1. So 1 by 1. Remember, even though it is limited to non-repeated linear factors only, whenever you have the repeated factors like this, for the highest power, this can be used. For the highest power, this can be used. For example, you have x cube here. You should not use it for x square, but you have to use it for x cube. Because your highest power is x square here, you can make use of it. That means, put x equal to 0. Put x square is equal to 0. Everywhere, but not there. Put x equal to 0. This is 1 by 1, 1. Are you with me? Put x equal to 0, 0, 0 plus 1, 1. 1 by 0 plus 1, 1. 1 by 1, 1. We don't know this. Let it be a. Because the shortcut is not useful here in this case. Because we take it as a. No problem. Now put x equal to 0. Put x equal to 0, please. What is that again? 0, 0, 1. Okay, we should not put x equal to 0 because this becomes 0 there. Let us put x equal to something like minus 1. Put x equal to minus 1. Put x equal to minus 1, please. Then what is that again? This is 2. Minus 2 gets cancelled. 1 upon. This is, even minus 1 is not also supported. So put x equal to 1 then. 1. Okay. Then 2 plus 2, 4, 5. 4 plus 1, 5 there. Here. 2 plus 2 plus 1, 5 by 1 into 1 plus 1, 2. 5 by 2 is equal to, this is a by 1 plus 1 plus 1 by 2. Just see that. X equal to 1, 1 by 2. Then a becomes, simplify this. A becomes 5 by 2 minus 3 by 2, 2 by 2, 1. So your a is 1 here. You see that? 4 by 2, 2 minus 1, 1. That's it. Even though it is not useful for the rest of the factors, I used it. By finding the values wherever it can be applicable, and I applied it, and wherever it is not possible, I have taken it as a. And only one unknown I have, so rest of them I have chosen some suitable value, like x0 not possible, x minus 1 not possible. That is why I put x equal to 1. By putting x equal to 1, I got a is equal to 1. Thereby all the partial fractions you have got. Next one please. X square minus x plus 1 divided by x plus 1 into x minus 1 whole square. Non-repeated linear factor and repeated linear factor. So this is x square minus x plus 1 divided by x plus 1 into x minus 1 whole square, please. See that one? See that one? It is non-repeated linear factor x plus 1 and repeated linear factor 2 are there. So 2 plus 1, 3 fractions must be written. 3 fractions must be written. So I'm writing x plus 1 first, then x minus 1, then x minus 1 whole square. What I said, The shortcut everywhere but not there can be used for the highest factor here, highest degree factor here. That is for x minus 1 whole square. Okay, let us come to this later. Now, put x equal to minus 1. Put x equal to minus 1 or x plus 1 equal to 0. Everywhere, but not there. Everywhere but not there. X equal to minus 1, please. This is 1 plus 1, 3. 3 divided by, this is minus 1 minus 1 minus 2 whole square, 3 by 4. Done. It is done. Coming to this, put x equal to 1. Put x equal to 1. Everywhere, but not there. Put x equal to 1. Everywhere, but not there. If you put x equal to 1, 1 plus 1, 2 minus 1, 1. 1 by 2. This is 1 plus 1, 2. 1 by 2. Done. And the middle one, we don't know. Let it be A. Let it be A. Or put x equal to 0. Put x equal to 0, please. If you put x equal to 0, this is 0, 0, 1. 1 by 1. Just see. And it is 3 by 4. 3 by 4 by 1. Yay. By minus 1. This is 1 by 2. Implies A is equal to, just to see that please. Just see that. A value please. Now this is put A to bring A to other side. A to other side. Then it is 3 by 4 plus 1 by 2. This is 3 by 4 plus 1 by 2 is 3 plus 2. 3 plus 2, 5 by 4 minus 1. 5 by 4 minus 1. 1 by 4. 5 by 4 minus 1. 1 by 4. So your A value is this. See how many steps I'm taking there. See how many steps I'm taking there. Otherwise you have to work out. If you want to follow the regular method, you have to work out. You have to take them as A, B, C, D. And you have to finally solve the equations and all, you have to solve them. But if you follow this method, it is very easy for you to do this. Okay, let us see. The next one, 3x cubed minus 8x squared plus 10 divided by x minus 1 whole power 4. The partial fractions also, you will be getting all this. Whatever the problems I solved here, just you will be getting this in integration as integral of dx. Integral of fraction of dx, you will get that. So all these in indefinite integration are to be solved in the similar manner. To save the time, follow this everywhere but not there. But remember, they are limited only to non-repeated linear factors. They are limited only to non-repeated linear factors. Now, if you see the first problem there, 3x cubed minus 8x squared plus 10 divided by x minus 1 whole power 4 is there. When the denominator is containing single factor with repetition. When the denominator is containing single factor with repetition, then simply take it as y. Simply take it as y. So, x minus 1 is equal to y. X minus 1 is equal to y implies x is equal to 1 plus y. See that please. Then replace the numerator. This is 3 into 1 plus y whole cube minus 8 into 1 plus y whole square plus 10 divided by y power 4. Just see that. Because we have taken the denominator as y power 4. Now, if you expand this, please, it is y cube, 3y cube. I'm writing directly plus 3y square into 3, 9y square minus 8y square plus y square plus 3y into 3, 9y, 9y minus 16y, 9y minus 16y minus 7y, it is plus 3, it is minus 8, plus 3, 13, minus 8, plus 5, divided by y power 4, divided by y power 4, divided by y power 4. I'm splitting it. Just I'm splitting it. Done. Done. Let us write y now. What is y here? 3 by, what is y? X minus 1. 1 by x minus 1 whole square. Minus 7 by x minus 1 whole cube. Plus 5 by x minus 1 whole power 4. Done. See the steps. How many steps we have taken? Just 3 steps we have taken. The third step we got the answer. You have to follow that. Whenever the denominator is containing single factor with repetition. Whenever the denominator is containing single factor with repetition, then take it as y and replace the numerator and then split the fraction to get the final partial fractions. Next one. See, whenever you understand the purpose of doing the problem. What is the purpose of doing the problem? What is the purpose of this topic here? Partial fractions. That means we are splitting them into fractions. Here also, the next problem if you see now, without applying any principle. What I mean to say, whatever the principle, basic principle we do in the board examination, or whatever the short form I taught you everywhere but not there, everywhere but not there, you can do it. How? The idea. What is idea? The denominator is x squared plus x plus 1. Numerator is x squared plus 1. What I'm doing now? What I'm doing, I'm creating x in the numerator. That is, I'm writing it as x squared plus x plus 1 minus x whole divided by x squared plus x plus 1 whole square. Just check it out. What is that I did? I have created the denominator forcibly in the numerator. That is by adding x and subtracting x. Now split it. Split it, please. If you split it, what is that you get? X squared plus x plus 1 divided by x squared plus x plus 1 whole square. Split it. Then what is that you are getting? 1 upon x squared plus x plus 1 minus x upon x squared plus x plus 1 whole square. Done, please. It is done. We have not applied any principles we know in partial fractions, whether they are Bode's method or the shortcut everywhere but not there. I have just made an adjustment by adding x and subtracting x. That's it. Okay. Let's go to the next one. The denominator is containing non-repeated linear factor. No problem with that one because we can make use of everywhere but not there. And another factor, it is containing a quadratic. It is containing a quadratic, please. So, what is that to be done? What is that to be done? This is what I'm doing. I'm taking up, as usual, this is done. Denominator, x minus 1. And this denominator, x squared plus 2. Nothing other than that we can do. Because x squared plus 2 cannot be split. X squared plus 2 cannot be split. Yeah, Arun? That cannot be split. X squared plus 2 as it is. There are no real factors for that one. So, put x equal to 1. Put x equal to 1 everywhere but not there. What is that? 2 into 1 square. 2 plus 3 into 1. 3. 2 plus 3. 5. 5 plus 4. 9. Divided by. Put x equal to 1 everywhere but not there. 1 plus 2. 3. So it is nothing but 3 by x minus 1. Done. Okay. Now, what is to be done next? Here. You have to write ax plus b. Just listen to that. Listen to that, please. Listen to that. 3 by x minus 1 plus ax plus b, because we don't know this and we cannot apply the short form here, I am writing it again, is equal to, what is a fraction, given fraction, 2x square plus 3x plus 4 divided by x minus 1 into x square plus 2. I wrote it. This is the fraction. One fraction we have got, second fraction is we find out. Carefully, see that. See that carefully. What is to be done now? You have to find out a and b values. Put x equal to 0. Put x equal to 0, please. Come on, tell me, what is that you get? Put x equal to 0 implies minus 3. This is 0. This is b by 2 is equal to 4 by 0 plus 2. 2 minus 1 minus 2. So this is minus 2 plus 3. B is equal to 1 you have got. Check it out, please. Check it out. What is that I did? I substituted x equal to 0. First, I used everywhere but not there by putting x equal to 1 everywhere but not there. In this fraction, I have got the numerator as 3 for x minus 1. And next, this is a quadratic in the denominator. Correspondingly in the numerator, you will have ax plus b. This is the quadratic. In the numerator, you will have the linear ax plus b. Someone is saying this voice is not clear. Is it correct? Just confirm, please. Next one. So, after getting B1 here, in my phone, I'm getting voice out. Mr. Dilip Kumar, check your speakers, please. This is B is equal to 1. After getting B is equal to 1, you ought to get A value now. How do? Just say this. Say this now. 2x squared plus 3x plus 4 divided by x minus 1 x squared plus 2 is equal to 3 by x minus 1 plus ax plus 1 by x squared plus 2. I use the value b now. Put x is equal to 1 now. We have to get the value of b. We put x equal to 1, 5 plus 4, 9 by, you cannot put x equal to 1 there because it becomes 0. Put x equal to minus 1 there. Put x equal to minus 1. This is 9 by minus 2 into 3 is equal to minus 3 by 2 plus minus a plus 1 divided by, this is 1 plus 2, 3. Now simplify this. This is minus 3 by 2 getting cancelled on both sides. Minus 3 by 2 getting cancelled on both sides. This is minus a plus 1 by 3. So these two getting cancelled. And if you write this, a is equal to, that is 0. A is equal to minus 1. Put this a minus 1 here. Put this a minus 1. Just see that. What is that we did? Please, others who are attending the session, please respond whether the speaker is clear or not, whether you are able to listen to my voice or not. Someone is saying here, Mookie drama, no voice clarity bol raha hai. Mr. Dilip Kumar is saying that. Just check it out. Please respond whether my voice is clear or not. Please. This is what I did. So, in the third problem, if you see, the denominator is containing non-repeated linear factor and a quadratic like this, then I put everywhere but not there, I got the numerator. And then, because it is a quadratic, numerator must have a linear factor ax plus b by x square plus 2. I have to get the values of a and b without using this shortcut everywhere but not there. So that is why I put x equal to 0. I'm putting x equal to 0 here. And thereby I got b. After getting b, 1. I wrote it there. This is b1, I wrote it there. And I have to get a now. I cannot put x equal to 1 here because it is already there. It becomes 0. That is why I put x equal to minus 1, and thereby I have got a is equal to minus 1. Thereby I have got the fractions, partial fractions. So, without applying the method, we have got the fractions here. Let us go to the next one. It is x cube divided by x minus 1 into x plus 2. Let me write that. X cube divided by x minus 1 into x minus 2. And very importantly, what is that you have to remember? Very importantly, what is that you have to remember? Whether it is a subjective question or whether it is subjective question in your board examination or objective question, the principles of partial fractions that are defined in the textbook are limited only to proper fractions. Only to proper fractions, but not for improper fractions. What is an improper fraction? If the degree of the numerator is greater than or equal to the degree of the denominator, even though it is equal also, it is said to be improper fraction. So to apply the partial fractions, to apply the principle of partial fractions, you have to convert that to a proper fraction, and then only you can do that. Here also the same case. It is an improper fraction. So x cubed by x square is there. If you divide x cubed with x square, because this is x into x square, x cubed by x square, there is no doubt you will get x. But when a cubic is divided by a quadratic, you will get a linear factor of first degree. That I don't know. Let it be a. I don't know that. That may be 1, 2, 3 or minus 1, minus 2, minus 3, whatever. Now, as usual, we will follow the method. What is the method? Non-repeating linear factors. This is x minus 1. This is x plus 2. Put x equal to 1. Everywhere but not there. 1 by 1 plus 2. 1 by 3. Done. It is done, please. Put x equal to minus 2. Everywhere but not there. Minus 2, minus 8 divided by minus 2, minus 1, minus 3. So what is that you get finally? X plus a plus 1 by 3 into x minus 1 plus 8 by 3 into x plus 2. Okay, so what happens now? If you put, we have to get the value here also, of course. How do you get this? No, this is nothing but quotient. When you divide x cubed with this quadratic. This is a quotient value. So you have to get the value of a now. Put x equal to 0. Implies this is 0 totally. 0 plus a. This is 1 by 3. 3 into minus 1, minus 3. This is 8 by 6. 4 by 3. Implies a value is 1. This is Minus 1 by 3 by 3, 1 minus 1. A value is minus 1. So your A value is this. Just see that. What is that I did? I have taken an improper fraction there. I have taken an improper fraction. In that improper fraction, what is that I did? First, I have to write the quotient, because partial fractions principles, whatever the methods are there, they are applied only to proper fraction. Whenever improper fraction is given, you have to write it as improper plus proper. Improper plus proper. To do that, like what? 7 by 2 is there. It is to be written as 3 plus 1 by 2. Then only it can be split as partial fraction. Just numerical example, just for better understanding, I am taking this. This is quotient. This is the remainder one. This is the divisor. So, this is x plus a is nothing but quotient. We don't know. X, we know. How you know? X cubed by x square is there. X cubed by x square is nothing but x. That's what I wrote. But constant I don't know. Plus a I have taken, and rest of them everywhere but not there. Rest of them everywhere but not there. Okay, it is done. It is done. Now, let us move on to the next question. X cubed by 2x minus 1 into x minus 1 whole square. Just see that. X cubed by. This is also an improper fraction. Just see that. This is also an improper fraction. X cubed divided by x 2x minus 1 into x minus 1 whole square. Follow this carefully, please. Follow this carefully. What is the numerator? X cubed. What is the denominator? X square into 2x. 2x cubed, don't forget that. Numerator is x cubed. Denominator is 2x cubed. That means the degrees of both the numerator and denominator is same. So x cubed by 2x cubed is nothing but 1 by 2. See that? You have to apply this technique. X cubed by 2x cubed, you have to write 1 by 2. That's all. In the previous problem we wrote plus a, no? We don't need to write that. We don't need to write that because x cubed, numerator, denominator, 2x cubed. Both the degrees are same. And what is that remaining? 1 by 2. That's it. Only constant. Only constant. Plus. Everywhere. But not there. It is x minus 1. It is x minus 1 whole square. See that, please? What is the technique I taught you? The technique what I taught you, everywhere but not there, can be used for the higher degree also. The higher degree factor. The repeated, in the repeated linear factors, it can be used for this also. Put x equal to 1. Everywhere but not there. X equal to 1, please. 1 by 2 minus 1. It is 1. Done. It is done. Now, put x equal to 1 by 2. Put x equal to 1 by 2. Everywhere, but not there. Put x equal to 1 by 2. That is 1 by 8 whole divided by 1 by 2 minus 1 whole square. 1 by 4, please. I'm writing this again. 1 by, this is 1 by 2 whole cube. 1 by 8 whole divided by 1 by 2 minus 1 whole square. 1 by 4. So what is that you get here? 1 by 2 plus 1 by 2 into 2x minus 1 plus, we don't know this, a by x minus 1 plus 1 by x minus 1 whole square. Now put x equal to 0 to get a. Put x equal to 0 to get a. X equal to 0. implies this becomes 0 totally. This is 1 by 2. This is minus 1 by 2. This is a by minus 1. This is 1. So a is equal to 1. Got it? Got it, please? That's it. So, even though this shortcut is limited only to non-repeated linear factors, we are applying it to repeated linear factors also provided. It can be used only for the highest power factor. And the rest of them, you have to take like this, A, B or whatever, and then give a suitable value, you will be getting. Okay, next, coming to the next one. It is x cubed divided by x minus a into x minus b. Just see this, it will be more clear for you now. You can do this easily now. What is the next question? X cubed divided by x minus x minus x minus. Now, this is see the numerator degree. See the degree of the numerator, please. X cubed. See the degree of the denominator. It is also x cubed. X into x into x, x cubed, x cubed, x cubed by x cubed 1 plus. See that? And rest of them as usual. What is that? Here, x minus a you will get. Here, x minus b you will get. Here, x minus c you will get. To get the numerator of, x minus a. Put x equal to a everywhere but not there. Put x equal to a everywhere but not there. So it is a cubed divided by a minus b into a minus c plus, put x equal to b everywhere but not there. It is b cubed divided by b minus a into b minus c plus, put x equal to c. Put x equal to c. Not there, but everywhere. It is c cubed divided by c minus a into c minus b. That's it, please. Done within one step. We did it. Within one step, we did it. Just check it out. What is the difference between the proper and improper fraction? Proper and improper fraction. In improper fraction, you have to just check the degree of the numerator and denominator. If they are equal, no worries. X cubed by x cubed 1 written plus the same method applied. What is the method? Everywhere but not there. Here, x cubed by 2x cubed. X cubed by 2x cubed means 1 by 2 plus same method everywhere but not there. Okay? Now, I'd like to show you how this is used in integration. Okay? See, now, the next question is x divided by x square minus a square into x square minus b square. Let us see that. X divided by integral of, I'm doing this. Why I'm taking up integration in partial fractions? There are problems in integration that are to be solved using partial fractions. So, if you see the denominator carefully, x square minus a square into x square minus b square, what I'm doing, I'm just creating the denominator and numerator. Like what? X into x square minus a square minus of x square minus b square. See the technique here. We are not applying any principle of partial fractions. Just we are using a method which we are, what is that we require? What is the purpose of doing partial fractions? Purpose of doing partial fractions is to get the given function to the standard format formula. To the standard format formula. What is the standard format formula? You will understand now. That is equal to integral of, split it now. X square minus a square, x square minus a square getting cancelled. So x divided by x square minus b square dx minus, split it. These two getting cancelled. X divided by x square minus a square dx. Done, please. But here, one more adjustment is to be done is that here x square getting cancelled, you will get 1 upon b square minus a square, because we have written that extra. We have written that extra. Unless we write that extra, we cannot split it, no? That is why. Because I multiplied the numerator with b square minus a square, I divided with b square minus a square. So here, what is that extra thing you will get for all this is 1 by b square minus a square. So take this minus common because x square minus a square is there. Let me write this in the beginning. So take this minus and apply it here. 1 by a square minus a b square. Now, if you see that carefully, the degree of the denominator is 2x square. What is the derivative? 2x. What is the derivative? 2x. So x is there already. X is already there. So what is that to be done? 1 by 2 integral of 2x upon x square minus a square dx minus 1 by 2 integral of 2x upon x square minus b square dx. It is nothing but 1 upon a square minus b square. Take that 2 common. 1 by 2 is common there. I have taken it out. 1 by 2 common, I have taken it out. Now f dash x by fx. 3 mar 2, 3 mar 3. 3 mar 3 integral of f dash x by fx log mod fx. So this is nothing but ln mod of x square minus a square. This is minus ln mod of x square minus b square. So log a minus log b, I wrote log of a by b. That is the final answer. See how many steps we have taken. We have not used the partial fractions here, but we used the technique of creating the denominator in the numerator, and thereby it is adjusted by writing 1 by b square minus a square. And after that, it is 3 mar 3 f dash x by fx log mod fx. 3 mar 3 we discussed in the video number 3. If you want to see that, just go through that video and understand. Okay, this is how in integration it is used. Let us come to the last problem then. Let us come to the last problem. It is why I have taken the problem. It is also related to integral only. That integral also can be written within one step. That integral also can be written within one step. What is that? Let me see. X square plus 1 divided by x square minus 1 into x square minus 2 into x square minus 3 dx is equal to, see, you may be getting doubt here because I said everywhere but not there is useful only for non-repeated linear factors, but here the power is 2. But don't worry about that because every term is consisting of x square. Every term is consisting of x square. You can comfortably apply that. Because every term is consisting of x square, but if only one term, if another term x is there, you should not apply. But here every term is x square. Take that x square as y. Yeah. Take that x square as y. That's it. Done. So everywhere but not there. So it is x square minus 1. And here also it is x square minus 2. Here it is x square minus 3. Now let me write this. Integral of, put x square is equal to 1. Put x square is equal to 1 everywhere but not there. If you write 1 here, 1 plus 1, 2. 2 by minus 1, minus 2. Minus 2 by minus 2, 1. Done. Okay, because all terms are consisting of x square, no x term, no higher degree terms, tan x square. Put x square is equal to 2. Everywhere but not there. X square is equal to 2. 2 plus 1, 3. 3 by 1, 3. 3 by minus 1, so minus 3. Put x square is equal to 3. Everywhere but not there. X square is equal to 3. 3 plus 1, 4. 4 by 2, 2. 2 into 1, 2. This is just a moment. 3 plus 1, 4. 4 by 2, 2. That's it. And after this, what is to be done? Everyone knows. Only one step we wrote. Integral of 1 by x square minus a square. 1 by 2a. ln mod of x minus a by x plus a. 1 by 2a. ln mod of x minus a by x plus a. Minus 3 by root 2 whole square. 1 by 2a. 2 root 2 ln mod of x minus root 2 by x plus root 2 plus 2 by root 3 2 root 3 ln mod of x minus root 3 by x plus root 3 plus c. Done. Done, please. Like this, the short form everywhere but not there can be used comfortably. Raghavendra, good afternoon. How are you? Good, you attended the class. I'm happy. See, without using the concept of partial fractions, now I have done this integration with the use of everywhere but not. So, if you habituate to this short form everywhere but not there, definitely the partial fractions goes very easy for you. The partial fractions goes very easy for you. In the next session, we will be discussing. The partial fractions problems, or the indefinite integral of partial fractions. Indefinite integral of partial fractions. In the next session, we will be doing that. Arun, respond. Arun. Respond, Arun. Arun, I have sent you the link. Arun, I have sent you the link of Discord. If you want to talk, please talk. You ask me any doubts. I'll be closing the session. Arun, connect. Yes, Arun.
Yes, sir.
Arun, you tell me. What's your doubt, Arun? Arun, respond.
Sir, yes, sir, I'm there. Sir,
You tell me, Arun. Is it partial fractions is new to you? Yes, Arun.
sir.
Tell me.
Yes, sir. Sir, yes, sir, I'm there. Sir.
Yeah, Arun. We'll connect again.
No, sir, it is not new to me.
Yeah, we'll talk again. In the next session, we will see the integrals of partial fractions. Namaste.